In this video, we will take a look at the meaning of trigonometric ratios of any angle. In junior forms, we have learned three trigonometric ratios: sine, cosine, and tangent. We learned that sine, cosine, and tangent are related to a right-angled triangle. Since theta is an angle of this right-angled triangle, therefore it has to be acute. That means it has to be smaller than 90 degrees and greater than 0 degree. Now in the senior form, we're going to extend the meaning of sine, cosine, and tangent for any values of theta. That means we can even find out or define a value for sine 120 degrees. For any values of theta, we can define a value for sine, cosine, and tangent. You may ask why we want to extend the meaning of sine, cosine, and tangent for any angle. Here is one of the examples of why we want to do so. Suppose we are given a triangle like this. Later on, we will learn that the area of this triangle can be given by this simple formula. Here is a quick example. If we have two sides to be 3 and 4, and we have a 70-degree angle here, then the area can be calculated as 5.6381 something. However, this angle theta can sometimes be obtuse, like this. If we have a 120-degree angle here, if we still want to apply this formula, we are going to run into troubles because we haven't defined sine 120 degrees. So in order to make use of this formula conveniently, we may need to extend the meaning of sine, cosine, and tangent for theta greater than 90 degrees. Now let's take a look how we can define the values for sine, cosine, and tangent for theta greater than 90 degrees. For sine theta, we know that it can be obtained by the opposite side of theta over the hypotenuse, which is 2 over 3.61. For cosine theta, it can be obtained by the adjacent side of theta over hypotenuse. That means 3 over 3.61. For tangent theta, it is equal to the opposite side of theta over the adjacent side of theta, which is 2 over 3. Now, in order to define sine, cosine, and tangent for theta greater than 90 degrees, we need to introduce a coordinate system to this right-angled triangle. In this coordinate system, the coordinates of P are 3 and 2. That means sine theta can be obtained by considering the coordinates instead of the opposite side. Similar for cosine and tangent, we can actually obtain the values of sine, cosine, and tangent by just considering the coordinates of P and the length of OP. That means the opposite side and the adjacent side are redundant in this coordinate system. In other words, from now on, in order to calculate sine, cosine, and tangent, there is no need to refer to a right-angled triangle. Instead, we can refer to the coordinates of P in this coordinate system. Since there is no need to draw a right-angled triangle to calculate sine, cosine, or tangent, that means theta can be any angle. It can be greater than 90 degrees or even a negative angle. For example, for angles greater than 90 degrees, sine, cosine, and tangent will be calculated in this way. Sine theta is still equal to the y-coordinate of P over OP. That means 1.87 over 2.46. Cosine theta is still equal to the x-coordinate of P over OP. That means that is minus 1.6 over 2.46. Tangent theta is still equal to the y-coordinate of P over the x-coordinate of P. That means that is 1.87 over minus 1.6. Therefore, to define sine, cosine, and tangent by using a coordinate system, this theta is not restricted to be an acute angle. It can be any angle, and sine, cosine, and tangent can still be defined. By considering this coordinate system, we can also define negative angles or angles which are greater than 360 degrees. For negative angles, it means an angle like this. For an angle greater than 360 degrees, it means that an angle which has more than a turn, like this. In short, a negative angle means an angle which is moving in a clockwise direction, and a positive angle means an angle which is moving in an anti-clockwise direction. To conclude, by using a coordinate system, we can define the values of sine, cosine, and tangent without referring to a right-angled triangle. And that means this theta will not be restricted to be an acute angle, and that's how we can define trigonometric ratios of any angle.